Welcome back, everyone. We have two types of estimates. First one is point, and the second one is interval. Based on the previous example that we took, we inferences the average height in that community is 70 inches. And this is a point. We said equal 70. We didn't put it in an interval. However, point estimate is not accurate because this value could be greater than or less than 70. So it could be 71, 72, 73, or it could be 69, 68, 67. So instead of having one point, we need to get an interval. So in the interval, we can determine our confidence level or accuracy. For example, let's say that the point estimate is 70, and the lower confidence limit of that interval is 68, and the upper confidence limit is 72. So we call this the width of the confidence interval. We can say that at 90% confidence level, the average height of people in that community is something between 68 to 72 inches. So 70 is the point estimate, and 68 to 72 is the interval. And interval is more accurate because the wider the interval, the more likely to get the actual value inside this interval. So there is 10% we could be mistaken in our estimate. There is a probability to have 10% error. So what if we want to increase confidence? Let's say we want to get a 95%. So to do that, we need to increase the interval. So instead of 68, we started the lower confidence limit from 65 to 75, a longer interval this time. And we did that because we want to be 95% that the actual value is located in this limit from 65 to 75. The more to be sure about our estimate, the more the interval length of the confidence level. And here the last example, let's say we want to be 99 sure the estimate of the actual value is accurate. We should this time start from 60 to 80. So this is the longest interval compared to the previous two. And the maximum is 99%. We cannot say 100%. To be sure that we are 100%, we should have the full population. So 99 usually is the highest confidence interval that we can use. And in this case, we are trading off interval accuracy. And there are two main conditions should be available in the estimate to be as close as possible to the estimand or the population measure. First, it should be unbiased, which means neither overestimate nor underestimate the population measure. So if you go back to our example here, we cannot exaggerate the estimate by taking a wider confidence. For example, we say the average height in that community is something between 40 to 100. So this is very wide range, and that doesn't make any sense, and it is unuseful at all. So this kind of estimate is biased. It doesn't provide us with a useful idea about the community. And the second condition here, it should be efficient, which means it has the minimum variability. And when we say the confidence level is 95%, that means there is a 5% chance the value isn't in this range. It is either bigger or smaller. So we refer to this 5% as alpha. Alpha is the error. And based on that, we refer to the level of confidence as 1 minus alpha. So 1 minus 5% equal 95%, which is our confidence level. And alpha is somewhere between 0 and 1. And this is the probability from 0 to 100. And when the confidence level equal 90%, that means alpha equal 10%. When alpha equal 5%, that means confidence level equal 95%. And finally, when alpha equal 1%, confidence level equal 99%.